Hi, my name is Nandini. Here I'm going to explain about the containers part 3. In previous part 1 and part 2 we studied about the fundamentals and practical uses. In this part 3 we are going to discuss about the real world applications, tools and best practices of containers. Here is the first slide. The real world use cases of containers are frequently utilized in microservices architectures to manage, scale, and deploy each services separately. CI and CD pipelines automate containerized applications deployment and testing. Next one is like machine learning, inference, APIs, and training enrollment in packages. Batch processing, complete tasks without having to worry about infrastructure management. Serverless workloads and API hosting, stateless, lightweight solutions. They are great for microservices when each services run its own containers. They are also used in CD and when the code is tested and deployed quickly. In machine learning, containers package models and dependencies. You can even use them for batch jobs, APIs, and lightweight serverless workloads. And next one is like AWS tools for containers development. AWS offers a number of tools to facilitate workloads that are containerized. First one is like Amazon ECR, safe storage for images. Through the Amazon ECR, we can save the images, automate building and deployment with AWS code pipelines and code build. CloudWatch, keep an eye and fix the issues. IAM, control granular resources access. App mesh, control communications between the services. And next one is like AWS DevOps with containers on AWS. Faster development cycles are made possible by containers. Docker allow development to test locally. Containers support fast DevOps workflows. ECS and EKS receives updated from CI and CD pipelines. This means like with CI and CD pipelines, you can automate deployment to ECS or EKS. Both the blue, green, and canary deployments are supported. Means you can even use advanced release strategies like blue, green deployments or canary releases to reduce downtime. Updated task definitions to quickly roll back problematic versions. Next one is like choosing the right container services. So how do you choose the right AWS container services? Through the when you want to greater control over the infrastructures, use EC2 or EC2. ECS and EC2. ECS and Fragment for more straightforward serverless setup, and EKS if Kubernetes already is in use. Light style containers for startups, short lived MBPS, and small apps. Performance optimization best practices. Make use of base images that are lightweight, like Alpine Linux. Second is reduce containers resources to prevent issues with noisy neighbors. For extensive development, run performance benchmarks, build layers and catch dependencies effectively in Docker files. Security best performance. Security is a critical for containers. Can check containers images for vulnerabilities on a regular basis. Easier does this. Assign IAM roles to ECS tasks or EKC pods to restrict access to other to the least privileged principals. Assign tasks to IAM roles. Use AWS Secrets Manager instead of hard coding secrets. Apply patches promptly. and maintain your containers images up to date. Monitoring and logging best practices. Always enable monitoring and log. You turn on CloudWatch logs for every containers. Use CloudWatch metrics to keep an eye on CPU, memory, and network utilization. For tracking, use Open Telemetry or AWS X-rays to identify unusual activities such as memory leaks and set alarms. Last one is cost optimization tips. For stateless and fault tolerant tasks, use Fragate Spot. Use smaller instance to run development and staging enrollment. Make use of right size instance and auto scaling when not in use, not production workloads. Schedule container services to terminate. Thank you.